In this first assignment, we're going to use a scientific approach to think about how the characteristics of ingredients affect the characteristics of the food that we make with them, using eggs as an example. I'll refer you to the second week's lecture for a more detailed discussion of egg protein chemistry. I'm just going to do a short version here. But what I really want to lay out for you here is that when we're setting up an experiment of this type, we'll devise a hypothesis, create a procedure for the experiments that are designed to test that hypothesis, and then lay out our results so that we can perhaps draw some conclusions from those. We're going to be doing egg foam, so we're going to be whisking up egg whites into foam. Here's an assumption. Egg foams are formed as unfolded proteins form aggregates around air bubbles. There's some terms that are still fairly unfamiliar to us here. Unfolded proteins. Assuming that proteins have some folded state that defines what their job is, when we stress them in a variety of ways, they unfold. And when they unfold, they begin to aggregate one protein to another. And when these aggregates get large, they form precipitates, in some cases almost gel-like structures. The hypothesis that I phrase here is, do additives that disrupt the folded protein structures stabilize those egg foams? That is to say, can we query the stability of the egg foam with a variety of different additives to that whisked up mixture? And the ways that we're going to measure it are to say, well, what is the volume of the foam that we whip up? And then as the foam collapses, can we measure the rate of that collapse as a release of water from the foam? So if the foam is stabilized by these chemicals that we add to the whisked up mixture, will the release happen more slowly? So you're going to measure that. Here's the procedure. And some of this procedure follows this little audio introduction with a video in a moment. So I guess step 0 would be to separate the egg whites, and I'll teach you how to do that in a minute. But then you're going to combine those 2 egg whites and whisk them for 3 to 5 minutes. Now I say no yolk because, again, the yolk of the egg is full of surfactants, right? Emulsifiers. They will prevent the foam or hinder the foam formation. So we keep out all of those lipids, those surfactant lipids. And again, whisk it up for 3 to 5 minutes until you get nice stiff peaks, and you'll see what I mean as you try it. So you're going to do that as many times as you like. I've given you 5 variations, and we'll talk about those again in a moment. And it's those variations that are going to teach us about the way the different additives affect the chemistry of the egg foam, and then what we can learn about egg foams in general from those variations. So again, measure the initial volume of the foam with a measuring cup or a teaspoon, or tablespoon, what have you. It doesn't really matter as long as you are precise and consistent in the way that you make those measurements. The same applies for measuring the volume of the liquid released. You can use a tablespoon if you like. I use a graduated cylinder in the demo after following this little intro. Follow it regularly. I don't really care what the intervals are, but do it regularly so that you can get a nice sense of how much water is being released when. And again, you could ask various questions. How many seconds before you get those gloss stiff peaks, and did that depend on the method you use? You might see if you can repeat this experiment 3 times using a fork or a whisk and see if you get the same results each time. Or you might compare a few different ways of whipping up those egg whites and see if they all give you different times to get to the same end point. The answer to that is obviously going to be yes with the electric mixer. What is the volume of the foam? Again, we're measuring that. And then what is the volume of liquid released over a period of time? So that's the experiment, and it's as simple as that. Now, let's look at the different additives that we can use to try to stabilize that foam. Each of these variations affect the proteins differently. Again, egg white is mostly protein, and we can control the way they denature depending on the conditions that we use. Let's skip the copper for a second and just talk about the acids. It's obvious what acids might do, as we talked about in the first lecture. They lower the pH. A question you might be interested in is what pH? And if you want to find that out, come by my office and pick up some litmus paper next week. So we can try different acids and see if some acids are better than others at stiffening the egg whites. We can also use copper. We'll use copper chloride. This again, any of these that you don't have yourself, feel free to come to my office hours and pick them up from me. Copper is an interesting case because it actually prevents unfolded proteins from interacting with each other too closely by protecting protein sulfhydryls, sulfur atoms attached to proteins, and we'll discuss this in detail in next week's lecture. That prevention actually stabilizes the foam because, as you'll see, if the aggregate is too tight, then water is squeezed out from between the protein molecules, and the foam loses some of its stability. For the chemists in the group, I've done some sort of back-of-the-envelope calculations here that take into account the fact that each of these chemicals have different molecular weights. So if you added the same mass or volume, if you're talking about a liquid, of each of these, you'd be adding actually different physical quantities of each substance. So to make sure we add the exact same amount of substance, the exact same number of molecules of each substance to each attempt, I've gone through these calculations, and then you can see where we wind up with. And so you can follow these recipes fairly closely. Feel free to experiment on your own, develop these recommendations, and as long as you document what you did and explain it in your report, that'll be fine. So really, I want to emphasize here that this is a bare bones activity, and you can expand on it at your will. So here's our variations: copper chloride, lemon juice, citric acid, cream of tartar, tartaric acid, that's a small organic acid, and vinegar, which we've mentioned before is acetic acid. Important for us to note that those three acids all have different acidities. That is, they ionize, if you recall, to differing extents, and so they're going to affect the pH of the solution differently. Okay, data collection. So I've filled this in partially myself, just from an attempt that I did, and it took me 5 minutes to whip it up with a whisk. This is actually using only one egg yolk, not two, just so you know. I got about 1 cup of foam. After the first 15 minutes, I got 2 1/4 teaspoons of water, and you can see how it went from there. So while we're here, let's think about the kind of graphics that you're going to present. You could do a bar graph comparing the different additives. You could show me before and after photos of the foam as soon as you whipped it up, and then after it had released all of its water. You could show a photo of the water released from the foam, etc. But again, use your imagination. Alright, I'll demonstrate how to separate an egg. So we're just going to give it a nice crack, and sometimes people are very careful to just get a little, just big enough portion of shell left behind to capture the yolk. It's not that important, but it is good to get a nice solid crack there. Gently separate the top of the egg from the eggshell from the bottom of the eggshell, like so. Peel it away so that the yolk stays behind in the larger half, and you see there's still some white in there, so I'll just kind of gently pour that off. You can see it seeping out the sides, and I can pour the yolk back into the other end, and you see yet more white rolls away. One more time, and there you go. So we've really separated most of the white away from the yolk. Very important not to crack your yolk into your white. The surfactants, the lipid surfactants in the yolk are gonna make it much more difficult to whisk up your egg white if you get any yolk in the white. So that's nicely separated. Okay, so here's our white. You can see the chalaza down in there too, that little white fluff thing. That's just a
sort of a cord that ties secures the yolk to the shell. I'm going to pour that white off into this crystallization dish and begin whisking. So this is a nice whisk. The more tines on your whisk, the better. You're just going to be able to whisk it up much more quickly. And you can whisk by hand, or you can use an electric mixer if you've got it. Whisking by hand like this, you can see. Oh, let's move it around. Maybe switch with you, please.
Okay.
You can see that it's already starting to foam up a little bit. By hand, it'll take about 5 minutes to get a nice firm foam. After about 2 minutes, you see that the foam is still, you're not really getting much in the way of firm peaks coming up. It's still pretty milky. So we'll keep on working. So after 4 or 5 minutes of whisking, you can see now that we're getting nice firm foam that holds its shape pretty well. If you went a little bit farther, you'd get even firmer, nice firm peaks. Very nice. Alright, so we'll wait for that to start to break down, and I'll show you how to measure the liquid released. So let's measure how much liquid has been released by the foam in 15 minutes or so. I have a graduated cylinder and funnel here just because I'm in the lab, but you could just as well use a teaspoon or tablespoon, whatever you have, just so long as you're consistent. That's the important thing. So I'm just going to pour this off, holding the foam in place with the whisk. I'm going to pour it down into the grad cylinder. Another drip for a minute. And we'll see how much has been released. Let's back up. So we can see that we've got about more like almost exactly 4 milliliters released in 15 minutes. And we could come back again in half an hour, and an hour after that, and an hour after that, and see on what time frame the foam is starting to collapse.